Our second lecture on 8.1 talks about line segments and rays. So a line segment is a subset. So we talked about subsets when we talked about set theory. So it's part of a line. So it's a subset of a line. And we denote it AB with a line across. Note that there's no arrows. Or we can denote it ABA, because we always read left to right. A and B are the endpoints. So remember, the line continued in both directions indefinitely. Now this line segment, it stops at A and B, so those would be the endpoints. And we read these left to right. A ray is also a subset of a line. This is a little bit different because it's going to contain an endpoint and all other points beyond. So we denote this AB, notice the endpoint, and then an arrow that shows that we would go beyond. We like to have 2 points that label the ray so we know which direction to head. Intersect, that happens when 2 lines have a common point, and we call that point the intersection point. Perpendicular happens when lines form a right, which is a 90-degree angle, and we denote that with kind of this crosshairs, and you can see that there is this 90-degree angle in those crosshairs themselves. So continuing with lines, we have a thing called concurrent, and concurrent is where 3 or more lines intersect at a single point. And we'll be showing some examples of these concurrent lines. We have parallel lines. Now, parallel lines, first of all, have to lie in the same plane and do not intersect. And we'll show a visual about lying in the same plane and why that is so important. So again, we need to realize why the same plane. And again, we'll be showing that in class. Skew is when 2 lines do not intersect. So that becomes like parallel. Lines do not intersect. But these 2 lines do not intersect because they do not lie in the same plane. Okay, and again, we'll show the difference between that parallel and skewness. So that concludes lecture 2 on line segments and rays.